Hi, my name is Lorenzo Scalabrini, and I'm the Technical Manager here at QT Motorsport. And I'm here to run through with you the design philosophy for the QV1 race car. So our QV1 is an all-wheel drive, all-electric, purpose-designed Formula Student race car. It utilizes an aluminium honeycomb monocoque as a chassis, and we also have a few key features on the car that we'd like to show you today. So we have the gearboxes, which we've integrated into the suspension uprights. We have our custom-built motor controllers or inverters, and we also have our battery management system, which has been integrated into each of the accumulator battery bricks. So I'll start with the battery bricks. So we have two accumulators in the car, and in total there's 288 6,200 milliamp hour lithium polymer batteries. We went for the lithium polymers because they're able to deliver a lot of current simultaneously, which improves the torque output of the motors, and they're also able to receive a lot of that current as well, which is beneficial for regen braking and conservation of energy under that. So the battery management system has been integrated into the PCB here on top of the battery brick. Now that PCB monitors the voltage output and the temperature of each of the cells during operation, and it also monitors the recharging of each of the cells during a recharging operation as well. So moving on to the inverters. These inverters are bespoke made in-house. They've been designed around the outputs of the Nova 15 Plettenberg motors. And they've been designed in such a way that they are much smaller in size compared to the other aftermarket options you'd be able to go with. And they're a lot more tailored for the output, so we believe there'll be much improvement compared to the aftermarket competitors. These inverters power our Nova 15 motors. Now they are a 15 kilowatt brushless DC motor, and they are water cooled as well. And they have such a great power to weight ratio that we're able to bolt them directly to the back of the gearbox here, which has been integrated into the upright. Now the gearbox is an epicyclic gearbox with a 4.5 to 1 reduction ratio. That ratio was designed around the upper speed expected from the Calder Park Raceway, which is around 120 kilometers an hour generally speaking. So the uprights have been billet machined from 6061 aluminium, and the gears inside are made from a 4140, which has been nitride treated as well for hardening. Moving on to the chassis. We have an aluminium honeycomb chassis with a carbon fiber reinforced polymer wrap, which is 200 GSM, the thickness of the carbon fiber. And we found that the aluminium honeycomb was a very beneficial and easy choice compared to space frame, because we were able to create a very precise chassis in a very short amount of time. So simply we had the flat material, which was routed, folded, and we were able to glue and fix it from there, which for our team was a lot easier than going down a space frame route. It also has a much larger, generally speaking, a much larger torsional rigidity, and that is improved by the carbon fiber wrap on the chassis as well. We did have to include side impact skins onto the rear as well, and that's just for intrusion rules and just to bump up the strength of the rear there as well. Talking about the suspension, we have designed the suspension around the Hoosier 10-inch R25B tyre. We chose the 10 inches over the 13 inches for their smaller mass and lower inertia, while they're also able to provide a similar load capability. So there really wasn't any attractiveness of going to the 13 inch over the 10 inch. We went for a wheelbase of 1530. Now the 1530 wheelbase was chosen for transient situations, so that's its ability under cornering. This was a toss-up against the load transfer under braking, which wasn't really an issue for us because we found that the benefits from cornering far outweighed any excessive load transfer for the track that we were competing in at Calder Park, where there is a lot of tight corners and such like that. The track similarly has been set to 1110, 1.1 meters essentially. This is to make the most amount of space out of the track which was available, and make the most out of the track that was available, and also the target weight distribution for this vehicle was 50-50. We're going to achieve this by putting the driver directly in between the two wheels here and putting the chassis blocks directly behind the seat. So I'm happy I got to run through the QV1 with you, and I hope to see you down at Con.